The topic is about PN junction diode. So we have seen separate P and N type materials where P has majority carriers holes and minority carriers electrons, and N has majority carriers electrons and minority carriers holes. P has acceptor atoms and N has many donor atoms. So when we are going to join the P and N material, what happens is the PN junction diode. Diffusion is the charge flow from high concentration region to low concentration region. The holes moves, negative ions are created, electrons moves, positive ions are created. So region close to the junction acquire the negative and positive charges since holes moves from its place to the N side and electrons moves from its N side to the P side. So the ions created are there near the junction. So we have a charge density here rho. Shape depends on the doping level of the diode. So this is the charge density here. Near the P side we have negative electrons since holes moves from its place and negative ions are created. Here the N side electrons moves from its place towards the P and positive ions are created here. So this region is called space charge region or depletion region. The width of the depletion region is 1 micrometer or 10 to the power minus 6 meter. So this is the depletion layer here. So for example, if P is more heavily doped, it is if bigger size than the N type, doping in P side is greater than the doping in N side. To maintain the charge neutrality, what happens here is the electrons in the ions, the negative ions in the P side is less than the positive ions in the whole side to maintain the charge neutrality. Biasing, in forward bias we connect the P side towards the positive of the battery and N side towards the negative of the battery. So what happens here, these holes when it comes towards the battery, it gets, since both are positively charged, it gets reflected by the battery, goes towards the N side. So these electrons gets repelled by the negative of the battery and goes towards the P side. So more recombination happens here. The electrons and holes recombine and the charge, the barrier potential reduces. So as we increase the forward bias voltage, more recombination happens here and the barrier width, the depletion width reduces for the forward bias to PN junction diode. Same, so as the voltage increases, the stage is reached where the barrier potential effectively disappears and charge carriers can easily flow across junction. In reverse bias to PN junction, P is connected to the negative of the battery and N connected to the positive of the battery. So the majority carriers gets attracted by the battery. Minority carriers gets repelled by the battery. In P, minority carrier electrons gets repelled by the battery, goes towards the N side. Same way for here also, N side also. The minority carrier electrons of N side gets repelled, goes towards the P side. Majority carriers gets attracted. So because of this, the depletion width between the reverse bias increases since there are less charge carriers here. In reverse bias, the current conduction is only by minority carriers, and so it is very small current in the range of microamps. We have IC naught, the reverse saturation current. It is highly temperature dependent, and for every 10 degrees Celsius rise in temperature, IC naught doubles. The reverse saturation current is small amount of leakage current which happens in the reverse bias. It is less than 1 microamps for silicon and greater than 10 microamps for germanium. The breakdown voltage in reverse bias, the velocity of the minority carriers crossing the junction increases. Since velocity increases, kinetic energy half mv square drastically increases, and so more movement of charge carriers happen. We get sufficient energy, collide with each other, and the breakdown happens in the reverse bias. So this is the volt ampere characteristics for PN diode in forward and reverse bias. For positive of the battery connected to anode is forward bias. We have an ammeter to measure the current and voltmeter to measure the voltage. So in forward bias, as we increase the voltage, current increases slowly. It starts conducting after the cut-in voltage of diode, which is nearly 0.7 volt for silicon and 0.3 for germanium. So after that, it starts to conduct. Current increases. This is the knee of the curve and this voltage is knee voltage. In reverse bias, positive connected to the cathode and negative connected to the anode of the diode. And we have the ammeters in voltmeters for measuring the current and voltage. So here breakdown happens. So as the voltage increases, current increases slowly, and after some time the voltage is somewhat constant and current increases rapidly. So this is regarding the forward and reverse bias in PN junction diode. Thank you.